Thanks, Dave. Welcome, everyone. This is our fourth briefing of the 5 that we've got planned over this summer. I'm a principal research scientist at the Bureau of Meteorology in Melbourne, and it's great to be here. I'll pass over to Alistair, who's going to kick us off. You're on mute, Alistair.
I'm still Alistair, and I'm still based at CSIRO in Hobart. And I've been working for a while with Claire on developing forecast products and thinking about how we help communities around Australia that are dependent on marine resources to adapt. It is the fourth briefing. The motivation remains the same. We are seeing extremes over the summer. Since we began these briefings in June, we have seen the things that we forecast emerge, and I think they have proved to be challenging in particularly Southeast Australia. We're continuing to look at the forecast performance, and we're bringing you, research, I suppose reasonably mature research products in order to deliver this information, but we continue to try and improve the forecast performance and are looking to see how forecasts can help with the planning decisions that many of you make in our marine estate. Just want to talk a little bit to remind us about how marine heat waves form, and then some of the things to be wary of when we're looking at how forecasts can be useful to us and what to be wary of. Around Australia, they form from two main functions: advection of warm water, which is currents bringing warm water further south on both coasts of Australia. They also form from atmospheric heat input, and think of that as sunshine. One of the things is easy to forecast, where currents are going. Where sunshine is going to appear is more difficult, and I'll talk to that in a second. Given that they can form by currents or by heat from the atmosphere through the form of sunshine, the frequency is modulated. The frequency is influenced by climate drivers like ENSO and by global warming. So as the planet continues to warm, we will see more extreme events like marine heat waves. The word modulation means once a marine heat wave is in progress or is likely to form, things like cyclone, monsoonal winds and local weather can interrupt the expression of a marine heat wave. For example, we find it very difficult to predict at lengths of 3 months or more into the future the weather, and that's things like the clouds, the rain or the sunshine. And so in this plot here, it shows over a number of days towards the end of a calendar year, how much heat was reaching the surface of the ocean. And there are some days where the bars are quite high and there's a lot of heat, and there are some days where there's much less heat. That's very hard to predict 3 months, 3 months into the future. This is what a marine heat wave would look like given this kind of heating. When the amount of heat increases in the surface from sunshine, the heat wave gets a little bit warmer. You see towards the middle of this plot, we had 2 really hot days in a row, and the heat wave in the ocean got a fair bit warmer. Then there were a couple of cloudy days and the heat wave cools off. And so this modulation happens over the course of a marine heat wave. And so on clear days and cloudy days, you can get this quite sudden increase in the amount of heat. And it's particularly important for inshore and sheltered coastal waters. So people in farming businesses, for example, oysters in shallow water, the marine heat wave forecast will give you general conditions, but you really have to keep an eye on the local weather because that's going to be these clear days and cloudy days, and we can't forecast that many months in advance. The second challenge we have with forecasting is with even shorter term events than marine heat waves, like cyclones. And Claire and I will use cyclones as an example because they have already been prevalent this cyclone season in Australia. In previous briefings, we've said that, generally in the eastern and northern regions of Australia, we'd expect around 3 or 4 cyclones a year in the El Nino period, but we can't predict them 3 or 4 months ahead of time. We've already seen 2 happen this year, and they've hit pretty much the same area of Australia in North Queensland. Fortunately, these events were not sitting on top of a hot ocean or a marine heat wave. If they had, I think the impact would have been even worse. And we already think they've been dramatic, but with heat waves underneath them, they would get really a lot stronger. And that's because the formation of cyclones or cyclogenesis, it gets its energy from the marine heat wave. So if you look at the figure in the middle, it shows a a cyclone beginning to form above a marine heat wave, and it collects that energy from the ocean and it really intensifies that atmospheric circulation. Then as a cyclone moves off on a particular track, it may actually lead to cooling in the ocean because that energy is actually starting to mix the ocean. And we can see both of those things happening in examples around the world. And on the next slide is an example of where that cyclone in the Gulf of Mexico in 2018, it went over the top of a marine heat wave. And that really energized that cyclone. And it was the biggest thing to smack into the Florida region on record. Huge amount of dollars in damage and fatalities associated with that track. And it got its energy from a marine heat wave. The second example I have is that where the cyclones disrupt a marine heat wave. In this case, Western Australia had a marine heat wave already in progress off its coast, and then a cyclone passed over the top of that heat wave area, and it led to that mixing and injection of cooler water that I described in the first couple of slides about cyclones. And so that led to some cooling, as you can see in the right-hand plot, and that might have been pretty good for some areas of the ocean. Unfortunately, cyclones bring a range of negative effects for people living near them, so I wouldn't be arguing for more cyclones as a benefit to disrupt heat waves, only that these are examples that make forecasting a long way out very difficult, and they will make our forecasts sometimes not appear exactly as emerges.
Okay, thanks, Alistair. So that was a bit of a primer on some of the drivers for marine heat waves. I think it's always we focus on the big drivers. ENSO is a big one, but just keeping in mind that there's lots of things in play, and your local region may be driven by different factors to say, the next state over, for example. So this section here is about what's been happening over the summer to date, and then I'll step through into the forecasts. All right, so I've kept a very similar format to the last few presentations, just to keep it consistent. So here on the left, this is for the Australian region as a whole for sea surface temperature. So it's the top metre or so of the water column, or less, since 1900. So it's the baseline that we've used is 30 years from 1961 to 1990. So these bars here on the left show whether it's warmer or cooler than that average period for each month. So December, because we don't have the January data yet, so it's only the 2nd of February, sorry. So we don't have a full month to show here. But what I wanted to show here was that December was really warm, and it was the 7th warmest on record for Australian waters. You can see here over on the right, if we have a look here, this is as a map. And so this is just coloured based on sort of the rank of the sea surface temperatures around Australia. So this orangey colour here, the second colour on the colour bar, that's in your top 10%. And so for a marine heat wave, the definition is in that top 10% of the historical record at that location. So you can see for December, it was pretty warm, particularly for the New South Wales, all through Victoria, Tasmania across the south coast, and for the bottom of WA. Everywhere else was still pretty warm. The only real exception here was the Northwest Shelf, which you'll see in the following plots was actually cooler than usual. We step through, this is a snapshot from last week, so it gives a bigger picture. What I've concluded up here in the top right, if hopefully it's not too small for you, is what I showed last time. So this here, when we're talking about El Nino, that's what's happening in the Eastern Pacific. So the typical pattern is warm, what we would say is a warm tongue, warmer than normal, top surface ocean temperatures heading across to the west. And you can see that, if you can see up in the top corner here, the heat has come further across the Pacific. And then we've got this buildup of heat in the Tasman Sea off the south coast of Queensland and around Tassie. So anywhere that's pink is warmer than normal. Anywhere that's blue, and unfortunately there's not much blue on this plot, is cooler than normal. Is a little bit of blue here on the Northwest Shelf, which is reflecting what we saw in the December plot as well. So that just gives a bigger picture, which is important because there's lots of things at play that are affecting our waters around Australia. Marine heat wave tracker. This is just a snapshot. This is just one day. This is the 29th of Jan. That was the latest one that was available. And you can see there's marine heat wave conditions here off southern Queensland, a little bit off New South Wales, and still that consistent story down here off Tassie. But as I'll show you, we step through, it looks like this event here, the marine heat wave event off Tassie, is breaking down inshore and is further offshore now. So hopefully the start of a good news story there. Okay, we also had feedback from listeners last time. People want to know what's happening in the subsurface. Obviously, fish don't live in the top, few centimetres of the water column. So this is based on observations, and we've got lots of floats and drifting buoys around that give profiles of the ocean. However, we don't have as many of those to provide a complete picture, but this is our best guess of what's happening in that top 300 metres. So the areas that are white around here, that's the shelf. It's shallower than 300 metres. We don't have this particular variable here. But you can see offshore, there's still quite a bit of heat, and that lined up with that marine heat wave signature we saw in the earlier plot. A little bit in the Coral Sea, some still offshore in Tassie, quite cool off the WA coast, and some cooling as well at depth across the Bight, and still warm off in the Southern Ocean here as well. So that also feeds back to what Alistair was saying. So if that heat is all the way through the water column, it's at depth, much harder for it to be disrupted by, a strong sea breeze. But if it's only in the top, few centimetres of the water column, much more chance of that being mixed down if you have a few windy days. But if you've got a big store of heat already sitting there, it's very hard to disrupt that unless you have a big event or, the drivers that are producing that heat change. Oh, and that was what last time looked like. So the 8th of December, and you can see that heat that was off New South Wales, bit of Victoria and Tassie is not quite as pronounced now than it was back then. Okay. Oh, we've missed a slide. Sorry. Okay. Maybe it might be hidden in there somewhere. So how did the recent forecast perform? So these are what I showed on the 8th of December. So we haven't had 2 full months since then. So what I've shown here is the first half of December and the second half of December. That was what was in the briefing, and then the forecast for January. Down the bottom, we have got the observed conditions. We didn't have fortnightly plots here. So if you look at these top 2 here for December, the average of those roughly equals what I'm showing here in the observed. This is all from satellite, the observed data, and it's that top layer. So as you can see, the model did a pretty good job. We've got that warmth down here that we predicted around Tassie. It was a moderate to strong marine heat wave and also parts of Victoria. And you can see that's what was actually observed. So the bottom one is observed, the top's forecast. We didn't see much of this. The model was predicting that there was some heat building up just off the north of Australia. That wasn't observed. And then we had this persistent heat sort of the southwest in the Southern Ocean here that the model forecast and that we also saw. If we step into January, so this is the observed, sorry, I'm just looking around the corner of my screen. This is for most of January here, and it's a pretty similar pattern as well. So we can see that we did observe moderate marine heatwave conditions down parts of Queensland, down New South Wales and off Tassie as well. And you can see that's what the forecast predicted. We did predict some marine heatwave conditions off Northern Australia that weren't observed. Parts of that may have been a contribution of some of the cyclone activity and monsoon, but we did over-predict conditions there. Okay, so I have somehow lost the slide for the sea surface temperatures. They will be in the slide pack though. And they actually looked pretty good. So make sure that they're included. And so when you want to go and have a look at those, they will be released with the recording. Okay, so stepping forward now. So this is from February through to April. And we'll have a bit of a look at the drivers as well as more local conditions around Australia. So this is a global picture here. And just as a refresher for everybody, when we're talking about ENSO, so La Nina, El Nino or neutral conditions, there are lots of different indicators that the Bureau looks at before they declare an event. One of these indicators is the Nino 3-4 index, which is basically the average in this box here in the Pacific. And that gives an idea of that gradient in temperature across the Pacific, which is one of the big drivers. So that is one thing we look at. We also look at the Indian Ocean dipole, so it's separate to ENSO. That's less relevant for us now. Those events tend to break down with the onset of the Australian monsoon. So that event is in the process of breaking down now. The monsoon was quite late this year. So February forward in time, the IOD or Indian Ocean dipole is not usually a player in what's happening around Australia. So you can see here, this is the that warm tongue that I showed you in the observations. We've still got some heat here in the Tasman Sea, a bit around Tassie. So warmth in the Coral Sea and across Northern Australia. So let's have a bit of a look at those in more detail. Okay, so ENSO. The El Nino event is underway, but looking at various indicators, it's showing that those temperatures in that box that I showed you in the Eastern Pacific have peaked now and they're on the decline. So the Bureau is expecting that neutral conditions, so not El Nino, not La Nina, were expected to return in autumn. The positive IOD event, which was just exacerbating the effect of the current El Nino event, is near its end. So here you can see this is the Nino 3-4 forecast. So this is what we've observed. This grey spaghetti is all the model forecasts that we run. And that gives an idea of the probability of the outcome. So you can see this green line here is the average of that grey spaghetti, and that is heading below this pink dotted line, which is the threshold for that indicator. So you can see around April, May, that particular indicator is heading back into neutral territory. So Bureau also looks not only at our own model, but a bunch of other models from international groups, and they're all pretty much in agreement that February, the El Nino event's still underway, March is starting to back off, and April, a few models are saying it's already in neutral. We're saying it's just above, but the story is the same, that the event has peaked and it is now on the decline. So the next two components are the rainfall and air temperature. So they're important forecasts to look at if you're inshore. Everyone loves a weather forecast. There's so many weather geeks out there. So that's an important part of your planning as well. You don't want to just look at an ENSO forecast and say El Nino equals hot. Because as Alistair said, there's lots of drivers and there's lots of interplays in the climate system. That is one of the big tellers, but not the only one. So rainfall outlook from February to April is drier than normal for most of the country, and that's pretty typical during an El Nino event. So an El Nino increases the chance of drier than average. So on the left is the chance of exceeding median rainfall, which is pretty low for most of Northern Australia. On the right-hand side is a forecast showing unusually low rainfall. So that what is the chance of being the lowest 20% for that season in that location? And you can see there's quite an increased chance in Northern Australia for much lower than normal, so in that bottom 20%. These maps always seem to be red. It seems to be warm quite a lot this season. So this is showing the air temperature outlook. So this is over land and it's showing warmer than normal. So on the left, it's showing warmer than the median temperature, so pretty much everywhere. High chance of exceeding the median. On the right, similar pattern to what we saw in the rainfall. This time we're looking at unusually high day temperatures. So top 20%. So in the previous plot, you saw Northern Australia. Pretty much the northern half of Australia is predicted to be much drier than normal. It's also going to be much warmer than normal over land. Okay, now let's get off the land into the water. So these are the two forecasts for the next 2 fortnights. So essentially the first half of February and the second half. This is sea surface temperature. This is the top meter. And the grid cells, if you can see them on your screen, these little boxes are 25 kilometre by 25 kilometre. So it just gives you an idea. So it's not super granular right down at the coast, but it will definitely give you the idea of the conditions around you. So as you can see here, for the next 2 fortnights, that cooling on the WA coast and northern WA is set to continue. So cool on the northwest shelf and down the WA coast. And we were discussing this earlier today and having a look at what January, February in 2016, when we also had an El Nino event happening, and we also saw these cooler than normal temperatures. So that's not unexpected to see that around WA. On the east coast, we've still got some persistent warmth. So anywhere that's sort of pink to purple is 1.5, 2 degrees warmer than you'd normally expect for this time of year. So it's still pretty warm, sort of from about central Queensland, central GBR, all the way down the WA coast for the next fortnight and off the east coast of Tassie. And then similar story, but the heat seems to be backing off a bit in the second half of February. So there's still heat down here in New South Wales, southern Queensland, a little bit off the coast of Victoria, and still a bit of heat around Tassie. But if you remember from our last briefing, this heat was much more pronounced around Tasmania in particular. To go with that, and I know I always talk about it, but it's really important, you need to look at the forecast accuracy. So this is available with the forecasts. I'll provide the links at the end of the presentation. This is where we've looked at how well is the model done at this time of year when we're looking this far ahead at this spot. Anywhere that's green, the model does a good job. When there's a really big climate driver, like an El Nino event, the model tends to do better than where it's neutral conditions and your area is being driven by just local weather. So the one on the left is for the first half of February, the one on the right is for the second half, and you can see the model has got pretty good skill or performance based on the last 40 years. So you've got reasonable confidence in those two forecasts. Okay, let's look a bit further out. So now we're looking at March and April. So these are monthly averages. You can see here that heat's hanging around on the east coast. So this is relative to what you would expect in March. So it's 1 to 1.5 degrees warmer than what you'd normally expect in March and April. But that heat is hanging around. So you need to bear that in mind. It's also building up across northern Australia. So off the Kimberley, not Pilbara, and through the Gulf. There is a bit of a reprieve down forecast for around Tassie. There's some cool water down here, and the heat seems to be moving offshore. So we've got reasonably high SST anomalies. So, there's fair bit warmer than normal, but it's not right inshore on the coast. And that cooling that we've seen around WA and the Bight, it's still there, but not to the same extent as we've seen in January and these in for February. Again, looking at the skill, anywhere green is good. Anywhere there's white, there's typically the model doesn't do well. So Northwest Shelf this time of year doesn't do a great job when you're looking this far out. And New South Wales coast, eddies, where they are really hard to forecast a long way ahead. So these little patchy bits, they pretty much look like eddies. That's where the model doesn't do a good job of getting the eddy in exactly the right grid cell. But for the rest of the region, we've got pretty good skill for March and April for forecast put out now. Okay, so now we want to look at the extreme temperatures. Top 10%, this is your threshold for a marine heat wave. February through March and April. So these are the same forecasts we've looked at in past presentations. They're trial ones, so they're not publicly available. But we can see here, so as we move through, this is looking at that grey spaghetti that we had on the El Nino plots. So we run the model 99 times and we look at how many of those forecasts are in that top 10%. The more forecasts that are in that top percent, the greater the likelihood that you're going to see a marine heat wave. So a few of the model runs are saying Coral Sea, 50, 60% chance of a marine heat wave. Tassie, it's pretty patchy, but you can see that that warm water that was off the coast is showing here it's high probability of marine heat wave. As we step through to March and April, there's a lot more forecasts indicating marine heat wave conditions across heading to the west. So particularly for sort of northern WA, their peak time, their peak temperatures, summertime temperatures tend to be in March. So this may be a concern for those operating out of that area. So this is a fair bit warmer than what is already your warmest time of year. April, it's starting to ramp up in the Coral Sea as well, and continuing across to WA. Tassie, however, has really backed off from what we were looking at in December. If we take all that grey spaghetti, those 99 forecasts, and we collapse them down and have a look at, on average, what's our marine heatwave conditions, you can see here for the same 3 months, fair few little areas in the GBR are lighting up, some off New South Wales, little patchy bits around Tassie. Starts to really cover the Northern Australia area for March and April. So Coral Sea all the way across Northern Australia. Again, the other thing to remember that Alistair touched on is it's also cyclone season. So the model doesn't include cyclones in this forecast. So if you're operating in this area, I'll be keeping an eye on both these forecasts as well as what's going on in your cyclone outlook, cyclone forecasts. And Tassie is really starting to back off. So that is good for everyone operating on the east coast there. All right, back to Alistair.
So through the series of briefings, we've looked at the evolution of marine heat waves. And when we started back in June, we called that the preparation window. We had some early signs that we would see strong warming in Eastern Australia. Probably the second and third briefings were dealing with the reaction period where the marine heat wave had started on the East Coast by about mid-November. We're saying today that we think it's peaked off the east coast of Tasmania. And so we're in this coping period now. We've just got to get through to when it ends in probably late February. That is later than we predicted in December. We had said that we thought it'd be gone by mid-January in February, but it's lasted longer than that. And then after it ends, hopefully by the fifth briefing in March, we'll be talking about the recovery period in Southern Australia, but Northern Australia will still be in this coping phase at that time. We talk about these stages because there are different actions that you can take depending whether you're in the preparation phase, the reaction, the coping, or the recovery. And so depending on those stages, there's a range of steps here. That will prime me for talking you through the next slide that I think is just interesting to see what has been the responses over the course of this year. For Southeast Australia then, we began these briefings in June when we were predicting events. We didn't have any maps that showed they would occur yet, but the climate drivers were starting to suggest we would see heat waves. By the second briefing in the August-September period, we had maps and forecasts. We're now in the during event phase, and again, our prediction is that by March, you'll be in a recovery phase. Northern Australia is lagging behind that. They are in this forecast phase now. There are maps showing that marine heat waves are likely for Northern Australia. And so by March, when we meet again, I think we'll know whether or not the forecasts were accurate for Northern Australia, and they'll be in the peak of those events there. So if we think about the 4 steps that you can do, the first is to assess the risk. And everyone has been through this stage, I hope now. And of the range of options that you can do on the table, I know that at least 4 of these have taken place in Eastern Australia. And I guess the ticks are a sign that our community has taken action in response to forecasting because we've got these things taking place. Groups have obtained baseline data and looked at where the historical heat waves have been. We've identified vulnerable areas and populations. People have looked at which industries will be most vulnerable, and a range of briefings have occurred for particular sectors that saw themselves as having a particular vulnerability to heatwave conditions. In the next one, the second stage, when we forecast it, how well did we use the preparation window? This is what Northern Australia should be thinking about now, but Southern Australia has received in our qualitative assessment these series of ticks. And so again, that's 2, 4, 5. That's 5 out of 8 things that we recommended in June last year have been done by 1 or more jurisdictions in Southeast Australia. And I think for everyone online who's been responsible for responding to these forecasts, I think that's a really great place to be, that we've had such great progress in response planning, thinking about mapping high priority areas, more bespoke forecasts being developed for some parts, including Tasmania. I think we've done a really good job through this forum and the activities of many online of educating decision makers with additional information and briefings. So we're not seeing surprise from our senior policymakers and political leaders when we're talking about the effect of marine heat waves. That's made some actions, I think, easier to take. For example, conservation actions or putting in place monitoring plans. Where we are now then is step 3 for Southern Australia, where the event's happening. I know there are data collection programs underway off the east coast of Tasmania and the east coast of New South Wales. There have been restoration and conservation efforts that have taken action in response to these forecasts, and I hope that we'll have an opportunity to share some of those with you in the wrap up to the season. But again, even while the events are happening, for the first time, we've seen a range of actions implemented in real time, and that's a great credit to this community. Looking forward to March then, for Southeast Australia, if you've got the appetite for it, you should be entering the adjustment and evaluation phase. If I'm in an industry, I might want to look at were the actions that we took sufficient and necessary. How long will it take animals to recover if they survive through the heatwave period? And that might be in condition of those animals. It might be in their readiness to undertake spawning at cooler times of years for some species. So there's a fair number of things to think about so that, again, you're better prepared for the next marine heatwave that arrives. And again, looking at Southeast Australia and the figure on the right, from the forecast that Claire just shared, by March and April, you should be through to the recovery phase. And it's really important, particularly the fourth item on this list here, to think about planning long-term management responses. A time between events is breathing space to get ready for the next one. Because the forecast that we'll leave you with today as the long-term forecast is a bit of a no-brainer. There will be more extreme events in future. And so while I think we've done a great job of preparing for this East Coast Australia event this year, there's more to come. And so the extreme event planning that some jurisdictions have undertaken, such as marine heatwave response plans, developing information sheets, putting in place data collection plans, those things will need to be ready to be rolled out in time for the next event. If you've done your planning well, it will be part of your long-term planning. And tools such as the Fisheries Adaptation Handbook that has led some fisheries jurisdictions in Australia to develop long-term response plans. For the federal government, development of the Climate Risk Framework by AFMA is another example of long-term planning that will help cope with climate. And for aquaculture, there's a project in development to be led by Beth Fulton that will be on helping aquaculture to make a better job of long-term adaptation planning. So I really feel pretty buoyed by the response and the way that we've responded. And that sets us up in a really good place for coping with these events in future.
Thanks, Alistair. So in the last couple of slides we've got for today, did get a couple of questions when we were talking to different fishery extension officers. Someone said, oh, someone's talking about La Nina now. We're just coming out of an El Nino. And so I thought rather we just would put it out there. So what about next summer? So there are some reports in the media at the moment that we're going to switch from an El Nino to a La Nina, which means there are strong relationships between marine heat waves on the west coast when there's a La Nina in play. At this stage, it is too early to forecast a La Nina in 2024, way too early. Even at the March briefing, it is too early. So, however, historically, about 40 to 50% of El Nino events have been followed by a La Nina. So it's worth keeping that in mind. Around half the years in the last, 120 odd years have been a La Nina or an El Nino. So they happen every sort of 3 to 7 years. But our strongest advice would be rather than just focusing on the La Nina or El Nino, because as Alistair said at the start, there are lots of things driving the ocean climate in your area. So keep an eye on the sea surface temperatures in your state and your region. Look at the rainfall, look at the air temperature as well for the next few months. And we will also have our last briefing for the summer on the 22nd of March. So I strongly encourage everyone to come along to that. We'll do a wrap up of the season and see where we want to go from here. It's been a really exciting space for us to be in this summer, in terms of the community engagement and participation. We've been really well supported by FRDC and all their great extension officers. So I think this has been a real success in terms of pulling the community together and various industries together in this space. So what we would, I'll go to the final slide. If you're not sure who to contact, these are the FRDC Extension Officer Network. And so Dave cleared with everybody that it was okay to advertise their email addresses on here. So please get in touch with your local rep if you're not already hooked into the network. There's one there for every state. They're all very friendly and will be able to direct you to resources as available. And on that note, these slides and the recording will be available. So if you missed it this time, you'll be able to get the right contact. That's it for this briefing. I just wanted to point to the two key links. One is the ocean temperature outlooks. These are where we draw all the SST forecasts from, publicly available. There's also the climate driver update. So the Bureau puts that out fortnightly. It looks at ENSO, it looks at what's happening in the Indian Ocean, and it gives a really nice summary in easy to understand language about what is going on, what's driving the climate around Australia. So that is a really great resource.